Alrighty guys, so we are going to start our new chapter today about linear functions. So hopefully we have those notes all set up. If we turn the page to our table of contents, the first thing that we're going to be talking about today and tomorrow is slope. So we'll put that here, and that's going to be on pages 51 and 52. Now, if you remember, we didn't put anything on this page. We didn't number it. So if we turn the page to 51 and 52 right here, I actually want to start on 52. So if I plot each of these points on a graph, so from this table, if I plot -2, -2, -1, 0, and 0, 2, I like to get a really nice straight edge and draw that line, which will continue forever in the same manner that it's going right now. And this would be considered a positive sloping line because as I read it from left to right, it starts down and ends up. And so that's why positive, because we're going up, like I'm walking up the stairs, because I would start here and go up, 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 up. So hopefully that kind of makes sense. Now, they take a look on the inside. If I have an equation like this, I can pick some x values to plug in. And because the denominator is 2, I would want to pick multiples of 2 to plug in. So you could do like 2, 4, 6, 8. I just went with the easy ones, 2 and -2. So if I plug that in, we'd have half times -2 minus 2. And half of 2 is 1, but it's negative. Minus 2 is -3. If I plug in 0, we'll have 0 times half, which is 0, minus 2 is -2. And then if I plug in 2, we'll have half of 2, which is 1, minus 2 is -1. So then I could go plot those points. So -2, -3, 0, -2, and 2, -1. So again, because the line starts down and ends up, that means it is a positive sloping line. When we're talking about slope, there's a bunch of different ways we can do that. One way is we can look at how y is changing versus how x is changing. So this is what we were doing like with our patterns before break. So when I go from -3 to -2, I go up 1. When I go from -2 to -1, I go up 1. So the change in y is always 1 versus the change in x. So from -2 to 0, that's up 2. And 0 to 2, that's up 2. So x is changing by 2. And so I can see that my slope is 1/2. So half. Now that also shows up in your equation right here. We can also use our graph to find the slope by counting our rise over run. So the way we do this is we start with our leftmost point, and I figure out how much I have to go up or down to get to the next point. So starting here, I have to go up 1. So I rise 1. And then I have to figure out how much I need to run or go left or right. And I have to run 1, 2 squares to get to the next point. So my rise was +1 because I went up 1. And my run was +2 because I went to the right 2. So again, I get half. Now the last way to do slope is to think about my slope formula, which we'll talk more about tomorrow as well. But right here's my slope formula. You really don't need to worry about the little 1s and 2s. But basically I choose 2 points. So let's say I pick 0, -2 as 1 point and 2 comma negative 1 as another point. Well, if I plug these guys in, so y2 is negative 1 minus y1, which is negative 2, all over x2, which is 2, minus x1, which is 0. Well, on the top, the two negatives will turn into a plus, and so I'm going to have negative 1 plus 2, which is positive 1, over 2 minus 0, which is 2. Okay, so lots of different ways that we can always find that our slope is half. Okay, now we can also have negative slope. So for instance, here if I plot these points, negative 1 comma 3, 0 comma 2, 1 comma 1, that would be considered negative slope because it starts up and ends down. Okay, so negative slope. And again, I can see that in many different ways. So if we open this up, we could plug in our x values to get our y values. So we'd have negative 2 times negative 1 plus 1. So that's going to be 2 plus 1 for 3. When I plug in 0, and again, with this one, it didn't matter which x and y's or which x I picked because it wasn't a fraction by the x. So 0 times 2 is 0, plus 1 is 1. And then if I plug in positive 1, we get negative 2 plus 1, which is negative 1. So I can also see that the slope is going down here because the numbers start big and end small. So that's kind of interesting. So we can plot these points, negative 1 comma 3, 0 comma 1, 1 comma negative 1. No straight line going. Ah! Oh no. It's okay. It's okay. I made a hole in my paper. Oops. So if I think about the change in y and the change in x, when I go from 3 to 1, I'm actually going down 2. And 1 to negative 1 is also down 2. So my change in y is down 2 or negative 2. For x, going from negative 1 to 0, that's up 1. And 0 to 1, that's up 1. So over positive 1, that can reduce to just negative 2. So there's my slope. I can also see that right next to x in my equation. I can also see that in my graph by counting rise over run. So if I count the rise, I still have to start from the leftmost point, so here, and rise is always up or down. I know rise sounds like I should go up, but I might have to go down. And in this case, to get to this next point, I have to go down 2 squares. So negative 2. And then run is left or right, and in this case, I have to travel right 1 square. So right is positive. So over 1, which again is just negative 2. And it stays the same no matter where you go. If I go from the next point, I still have to go down 2 and then right 1. So no matter where you go on the graph, your slope always stays the same. Excuse me. And then again, we can use our slope formula, but we'd still end up with negative 2 as our slope. We'll skip that one. I can also have 0 slope. So 0 slope happens when you are constant. So if I plot these points, negative 1 comma 2, 0 comma 2, 1 comma 2, this line is constant. It's just horizontal, and horizontal lines always have 0 slope. And the reason for that is, so I can pick whichever values I want for x here. So I'm just going to go with negative 1, 0, 1. So I have some negatives, some zeros, some positives. And no matter what, though, like there's no x for me to plug in here. Y is always going to be 3. So no matter where I go, y will be 3, giving me this horizontal line. Now, the reason that this is 0 slope is if I try change in y over change in x. When I go from 3 to 3, I went up 0, up 0. Now here I am going up 1, but 0 over anything is 0. And so their slope is 0. Also, if I think about rise over run, when I need to go from this point to the next one, I don't need to go up or down at all. So going up or down nothing is 0. And I run 1 or I run 2 or I run whatever, it really doesn't matter because 0 over anything is always 0. Now I can also get that by doing my slope formula, and it will be 0. And guys, we'll practice our slope formula more tomorrow too, so don't be stressing about that one. I can also see it in my equation because there is no x. So I can almost think of it as like kind of this imaginary plus 0 times x, because 0 times anything is 0, so it'll just go away. Now, last but not least, the last type of slope that I can have is undefined slope. And undefined slope is something that I cannot walk. So I can walk positively, like up the stairs. I can walk negatively down the stairs. I can walk straight across. But I cannot walk undefined slope. So with undefined slope, we go 2, 1, 2, 2, and 2, 3. So undefined slope is always vertical. I cannot walk straight up. It's not possible. And so it's kind of weird when we're looking at our equation, there won't be a y, there will only be an x. And so no matter what, x has to be -3. So I don't get to pick x here. It's always going to be -3, which that means that y can be whatever it wants to be. So I'll make y -1, 0, 1. So if we go -3, -1, -3, 0, -3, 1, we get that vertical line again. Now, if we think about this as change in y over change in x, y went up 1 and up 1. X isn't going up at all. That's up 0, up 0. And if 0 is ever in the denominator, that can't happen. You can't divide by 0. This is undefined. So that's why we call it undefined slope. Also, when I think about rise over run, I'm like, I guess if I start at this bottom point, I go up 1, but then I don't go left or right at all. So again, I'm over 0, which is undefined, which means that my slope here will also be undefined when I use my slope formula. And I can kind of tell from my equation, because my equation is strange and only has an x and doesn't have a y. And whenever that happens, you have undefined slope. So hopefully, guys, this little intro into slope is helpful. We will talk more about slope tomorrow. And there you go.